Guys, let's try this problem right here. This question is asking find the radius of convergence and intervals of convergence of the series. Now to find this one, what we do is we take the ratio test first. So to do the ratio test, we take limit n approaches infinity, and the general pattern to take ratio test is this one, an plus 1 over an, right? An plus 1 is wherever we have n, we have to add 1 to that. Now here we have this power n, this power n, this power n, so we have to add 1 to all of this. Now let's write this one. So limit n approaches infinity, this is going to be 2x minus 1 power n plus 1 over 5 power n plus 1 and then square root of n plus 1, right? And then we have to divide this one by original function. It's same as multiplying this one by its reciprocal, right? So let's multiply this one by this, its reciprocal. So reciprocal is 5 power n square root of n divided by 2x minus 1 power n, right? Now let's cancel everything we can cancel. From here we can cancel this one, and we are left with 2x minus 1 power 1, and then from this one we can cancel this 5 power n, we are left with 5 power 1, and these two are remaining, right? And this should be in absolute value. Now let's simplify this one. Limit n approaches infinity, here we have 2x minus 1 over 5, 2x minus 1 over 5, and then square root of n over square root of n plus 1, right? And this limit is only related to n. So we can take this 2x minus 1 over 5 outside because this is not related to this limit, right? Only n is related. So we can take this one out, and if we take this one out, this is going to become 2x minus 1 over 5, limit n approaches infinity, and then we are going to have in the absolute value, we are going to have this also absolute value, and here we are going to have n over square root of n plus 1. And if you notice, these powers are same. We have n power half, and here also same thing. So whenever we have same power, the ratio in front of it is going to be the limit. Here we have 1 in front of it, right? If we don't have anything, it means just 1. So this limit is going to be 1 over 1, so that's going to be 1, right? So we are left with this one. So this is going to be our final value, 2x minus 1 over 5, and whatever the value finally we are getting from ratio test is going to be less than 1, right? And then we have to find the intervals of convergence. To find the intervals of convergence, what we do is we bring everything except x to the other side. Now let's write this. 2x, therefore 2x minus 1 over 5 is between negative 1 and 1. So 2x minus 1 is going to be 5 multiplied by 1, that's going to be 5. And then 5 multiplied by negative 1, that's going to be negative 5. And if I move this negative 1 to this side, this is going to become 5 plus 1, that's going to be 6. And here, if I bring this negative 1 to this side, this is going to become negative 5 plus 1, that's going to be negative 4. Now we have to divide both by 2. So if I divide this one by 2, this is going to be negative 2, this is going to be 3, right? So this is our intervals of convergence. But we have to know whether it should be included or not. That's the main thing. To find that one, whether they should be included or not, what we do is we take this one and put this value in original form, original equation, like the first equation. We plug these two values instead of this x value and find whether that series converges or diverges, right? If it converges, we have to put it in close bracket. If it diverges, we have to put that one in open bracket. Now let's plug negative 2 for this x value and see what happens. So if I plug negative 2 for this x value, this is going to be 2 times negative 2, that's going to give us negative 4. And this negative 1, that's going to make this one negative 5 power n. So this is going to be sigma negative 5 power n over 5 power n square root of n, n is equal to 1, to infinity, right? Now we can take the negative 1 outside. So this is going to be n is equal to 1 to infinity, negative 1 power n and 5 power n over 5 power n square root of n. Now here we can cancel this 5 power n, 5 power n, and we are left with this one, that is sigma n is equal to 1 to infinity, negative 1 power n over square root of n. Now whenever you see negative 1 power n, this is an alternating series, right? So to find whether an alternating series converges or diverges, what we do is we take the limit, and if it is equal to 0 and decreasing, it converges, and if it fails one of them, it diverges. Now let's take the limit and see what we get. But to take the limit, we only take bn part. Bn part is basically the value except this negative 1. So if I avoid negative 1, the value we are going to have is 1 over root n, right? So we have to check whether this 1 over root n gives us 0. Now limit n approaches infinity. If you take 1 over root n, this is definitely 0 because 1 over infinity, that's going to give us 0. And also we have to find out whether it is decreasing. To find out whether it is decreasing, what we do is we take few values. Like for example, if you start from 1, if you plug 1 and then 2, and if you go further, you know that denominator is going to become bigger and bigger and bigger. So it's definitely decreasing, right? So this is decreasing. So this passes both of the tests, like both of the convergence tests. So this is a convergent series, convergent alternating series. So since this is convergent, we have to put this minus 2 in close bracket. Now let's see whether this 3 converges. To find this one, again we plug this in the original equation. So here we are going to have 2 times 3, that's going to be 6. 6 minus 1, that's going to be 5. 5 power n over 5 power n. N is equal to 1 to infinity. And also we have a root n, right? Root n. So 5 power n, 5 power n cancels, and we are left with 1 over root n. And this is a clear p series. We know that whenever we have p series, and if the value is less than, if it's 1 or less than 1, it diverges. So here we have this one power half, because root n is power half, right? So n power half, this is a divergent p series. So since this is a divergent p series, we shouldn't include this one in this series. So I mean this intervals of convergence. So this should be in open bracket. So we have to put 3 in open bracket. Now this is going to be our intervals of convergence. Now also they are asking for the radius of convergence, right? So we have found out intervals of convergence. Now we have to find out the radius of convergence. To find the radius of convergence, what we do is we take the highest value and subtract the lowest value from this, and then divide by 2. So this is going to be 5 over 2. So that's going to be the radius of convergence. I hope this helps. Thanks for watching.